So hello everyone, this is Easy Automation here, and as I promised in the previous video, today in this video we are going to create two projects. First one is for the trip indication of the motor and second one is for the redundant system where our program will operate one train on the redundant system. But before we start, subscribe to our channel if you are interested in automation. So in the first project, we are going to create one program which is for the trip alarm of the motor. So let's start with the program. So to create that program, I need to first delete this rung and add one another rung. I will just keep the start logic as it is because it will be used in this program as well. So I will just keep it as it is and add one NO contact here and one NC contact and one output coil for our motor. And I will add one another rung here for the alarm, add one output instruction, one NC contact and one NO contact. So let's just give the address. I will just use this on command here and this on command to this NO contact as well. And this NC contact will be our trip feedback. So I will just address it and name it as tripped and this coil as motor. And I will just drag this motor address to our NC contact. And for this output coil, I will name it as trip alarm. So this is how the program will look like. And the steps are, if I toggle this start button, our on command will get started. Then that on command will start these two rungs as well. And if motor is not tripped, then our motor will start. And if the motor is tripped, then motor will not start. And our trip alarm will get high. So let's check how it works. So now our program is in ideal condition. That means our NO contacts are NO and NC contacts are NC and no any output coil is energized here. So if I start our start push button and release it, then our on command will get started, and by using that on command our motor will start. And if our motor get tripped, then this trip feedback will get high and our motor will get off and the trip alarm will go high. And by hearing this alarm, the operator can fix the motor, and if the motor is repaired by the operator, then our trip will go low and this trip alarm will also stop here. So this was the program for trip indication of the motor. So now let's create one redundant system. But before we start, let's understand what is redundancy means. So redundancy means it's like a backup plan. So for explaining the redundancy, I have one example here of an electric train. There are often two or more motors powering the set of wheels. If one motor fails, then the other motor will automatically start and keeps the train moving. Maybe slower, but the train won't stop completely. So it is like the backup motor. If the primary motor fails to run, then the secondary motor will automatically start and move the train forward. So it is just like the backup plan if our primary plan fails. So now let's create one program here. So I will add one another rung here and keep this start logic as it is and add one NO contact, and after that I will add one branch instruction in which I will add two output coils and two NC contacts in both the branches. So this first coil will become our prime motor and this second coil will become our backup motor or the secondary motor. So I will just copy this on command to our NO contact and give address to our output coil. So for our first motor, I have given name as motor 1, and for second motor, I will name it as motor 2. And to create one interlock between these two motors, I will just drag the first motor's address to our second motor's NC contact and our second motor's address to our first motor's NC contact, so that if our first motor is on, then our second motor should stop, and if our second motor is operating, then our first motor should stop. It is for the condition where both the motors should not start at a time. So this was for it. And now these NC contacts will be our trip feedbacks of motor 1 and motor 2 respectively. So I will just give address to them. I will name it as M1 trip and for second call it as M2 tripped. So if our first motor get tripped, then this NC contact will become NO, and if our second motor get tripped, then this NC contact will become NO, by which our second motor will get off. And now for trip indication, I will add one another rung here and add one NO contact here and one branch instruction and one output coil and one another output coil, and I will just extend this branch down for the overall failure. I will add one another output coil for overall failure and add one NC contact in every branch, and for last branch I will add one another NC contact. So for this NO contact I will just copy this on command here, and for these NC contacts I will just drag the first motor's address and the second second motor's address. For output coils, I will name it as M1 indication, and for second one, I will just give address and call it as M2 indication. So if our first motor get tripped or stopped, then M1 indication will get on, and if our second motor get tripped or stopped, then our M2 indication will go on. And what if both the motors will fail to run? Then this final alarm indication should go on. I will just give address as alarm and give address from these two motors. So if our both motors are failed to run or stopped during operation, then our alarm will operate here and gives the sound so that the engineer can fix these motors. So now let's verify our program. Verified, no errors found. So now our program is in ideal condition. That means our both motors are stopped here and our train is not moving forward. But if I start this start push button and release this one, our train will start moving forward. But what if our first motor will get tripped? Then this trip feedback will go high and our first motor will get stopped. But the train is still moving because the backup motor, that is our motor 2, is on here, which is driving our train forward. And when our first motor is tripped here, then our M1 indication is on, which is the indication of the first motor is tripped or stopped here. And if our second motor is also failed to run or tripped, then both indications will on and one alarm will also generate so that our engineers can fix these motors. And to stop the train when it was driven by first or second motor, we just need to toggle this stop push button and untoggle this one. Then our first and second motor will get stopped and our train will stop here. So this was the overall idea behind redundant system, where if our first motor gets stopped, then there will be one backup motor which is going to continuously operate our operation. Like in this case, our train won't get stopped by first motor's failure. So this is the example of redundant system. So I hope you got the point and took the notes. And if you didn't got any point, feel free to ask in the comment section. I will always be there to answer your questions. And if you learned something new today, then do hit that like button and subscribe if you are interested in automation. And don't forget to share this video with your friends and colleagues. So with that being said, I'll be back in next video. Till then, keep exploring my previous videos. Bye.